Okay, in this video, we will continue with the Term 4 paper for the Set 3 Combined Science 2021 paper. So for question 4, it is basically your ray diagram. And when I teach you on how to approach ray diagram, the first thing you need to find out from the question is this real or is this going to form a virtual image? So down here, there is no information given from the question itself, but you can see that the object is more than one focal length away from the lens. So as a result, you should know that in this case, you would be expecting a real image being formed. Now, once you know that a real image is going to get formed, you should quickly sketch out the standard ray diagram whereby you will have a light from the object going through the optical center, and without any bending it will just go straight, and followed by this horizontal ray, and then it will converge towards the focal point and it will just go like that. So by drawing this standard model, you will see that basically there are a total of 7 points that you need to locate in order to complete this ray diagram. So once you know this, you can take a look at the question's ray diagram, and immediately you can see that you can actually form point number 1 over here. You know about point number 2, you know about point number 3, and that's it. So by comparing the left hand side and the right hand side, what is the thing that you can draw? So I hope just by looking at this, you can already see that there are 2 points you can link it up, right? So take a second. I will not say first. Can you identify them? So I hope you can see point 3 and point 1, you can draw the line already, right? So this is how you use the standard diagram to guide you to draw the ray diagram that the question wants. So from 3, you can draw to 1, and of course, because it is cutting the optical center, the light ray will not bend. So I do not have a ruler with me, so the reading will be a bit off. Now once I draw this line, okay, then what is the next thing I can draw? So look at the standard diagram, and you can actually see that since I have point number 3, you can actually locate point number 4, right? So down here, you can draw this, and you find that, now I know point number 4. And since you know point number 4, and you can see that there is point number 5 over here, you can actually tell from the standard diagram that you can link up 4 and 5 as well. So from 4 to 5, you can use a ruler and draw a straight line. Now once you draw a straight line, the more line that you draw, right, the more intersection point you will be able to locate. So down here, you can already see that an intersection point appear here. And this is exactly your point 7, right? So with point 7, basically you can already locate this is going to be your image. So you see, by just comparing the standard diagram with what you have in the question, you are now able to locate the image. Once you locate the image, the rest is simple. Any ray that come from the object, any ray will just converge, right? Any ray will just converge. So that is this simple. So I hope now you know how to approach this. Now for part B is more on memory work. You need to know the image characteristic. And by image characteristic, there are 4 categories: magnified, same size, or diminished. Okay, this category is what we call size. Then after that, we talk about the type, which is either real versus virtual. Then after that, you will have to talk about the orientation. There are only 2 types: upright versus inverted. So in any question, whenever they talk about image characteristic, they are referring to this tree. So you need to memorize them. There's no way that I can give you a shortcut. Okay, but I can offer you a long cut. Long cut means no need to memorize, but you need to be able to sketch the standard model very, very quickly. Okay, so if you want to learn that, do let me know, let your teacher know, and we will advise you accordingly. So I will not be covering that in this video. Okay, for question 5, most of you knows how to do it. It is just that your sign conventions are not correct. Please remember that all the rays that is inside the mirror will be virtual, and as a result, dotted line. Okay, please also make sure that your image distance and your object distance must be equal. Okay, and also take note for this question, I think the teacher didn't draw the position of the eyes properly, but somehow the ray will still enter your eyes. Okay, it's just that some of it will enter your eyelashes. For part A, basically it is content knowledge again. It's either you know it or you don't know it. Okay, so please go and learn the image characteristic formed by a mirror. It is in your textbook, summarized in a very neat table. Now, to explain why images are considered virtual, so we just need to remember that any virtual images are just images that cannot be formed on a screen. It's just a technical term for something that is very simple. Okay, form on a screen, cannot form on a screen. So if you still cannot buy into this concept, do text us, and we will have a one-on-one consultation with you. Okay, for B and C, basically it is on your ray diagram. So as long as you do your ray diagram properly, you should be able to score that mark. Okay, and if you can't, do approach us as well. Okay, what I can do is I can recap with you the steps. So step number 1 is always to measure the object distance, meaning from the object perpendicular to the mirror. Then after that, you will be able to locate your image by measuring the same distance from the mirror. That means from here, the green where to the dot. Once you do that, you can see that there are these two rays that is given by the question, meaning that it is going to strike the mirror at this point. So once you know the point of intersection, you then draw from the image a virtual ray to this point, and then you just continue straight. Okay, this is your step number 3. Then after that, just repeat for the other point, and you will be able to complete your ray diagram for reflection. Okay, for question 6, many of you have done a great job. So if you look at your part A to find your wavelength, many of you have remembered that actually this is one wavelength. So 100 kilometer is for 2 waves, and you'll be able to get this answer. Most of you encounter issue with this speed. Some of you try to solve the equation with f lambda, v equals to f lambda. Yes, you know the lambda, but actually there's no information given for frequency. So what you need to do is you need to interpret this diagram. So what this diagram is trying to tell you is that there is a wave first being formed at A. So at A, the wave first formed, and the rest of the water surface is flat. Okay, after 0.49 hour, which is given here, what happened is that this crest, the yellow crest, have actually traveled to B. So this crest has come here. So since you want to know the speed of wave, basically it is the speed of the crest as well, right? So now you know that the crest took this amount of time to travel from A to B. You also know that the distance between A and B is 350 kilometer. How do you tell this? Well, you know that this is 100, 200, 300, 350. So once you have this, you can actually make use of the very straightforward equation. Speed equals to distance over time. Distance traveled is 350, time taken is 0.49. So that's how you get the answer over here. Make sure that everything is in 2SF. Okay, so please complete your correction and submit to me for another round